Good afternoon. I thought I'd do some narrated killer Sudoku. Spare 20 minutes. Expert level. What is the point of narrated killer Sudoku? As we've discussed before, if you are just starting out on these puzzles and you're a bit overwhelmed by this, then I'm just trying to help you understand how I do these things and how you can do them and understand them and enjoy them as I do. Anyway, so where do we start? Always, we start with the easy ones. So, single cell boxes. So we've got 8 there and 8 there. What else have we got? No other single cell boxes. Double ones where you've got one solution. So we've got a pair. We've got a double here. 3. Got one up there. Oh, that's already sold. In fact, 3 and 1. 2 and 1. Okay, because we've got a 1, 5 has got 2 solutions. We've taken away one of them. Okay, looking for like other pairs, triples. Oh, we've got one here. We've got a quad. $30 only has one solution. The ones you're looking out for like single, for where you've got a single one, is things like 3, 4, 16, 17. Then on a triple, you're looking for 6 and 7, 23 and 24. On a quad like this one, you're looking for 10, 11, 29 and 30. And if you've got a quint, then it's 34 and 35. And I think it's 15 and 16. Yeah. Okay, over here, this 7 can't be 1 and 6. Oh, I thought it was gonna be more than that. Okay, let's keep looking. I missed that 5 there in the middle, didn't I? And what else to look for is remainders. So remainders are a situation where every line has to be 1 to 9, but it has to add up to 45, as does every square. So if you've got a situation where you have cells inside a box, like here, for instance, this is a remainder pair. So you've got 7 plus 14 plus 14. So that's 35, which means that this and this is 10. And you can use those to help you in neighbouring squares sometimes. But right now, I'm not seeing the obvious one here. Let's keep looking. Okay, this here is a pair with only one solution. Can't be 1, can't be 2, can't be 3. So it can't be the pairs of those either. It can only be 4 and 6. And if it can only be 4 and 6, that can't be 6, and that can't be 6. So I've got 5, 7, 8, and 9 are what's remaining in here. Okay, that can't be 5 because that would need to be 8. So the only place 5 can go is here. 6. So let's finish this square off. 7, 8, 9. And let's pair this off. 4, 5, and 6. Can't be 6. So it can't be 6. That can't be 7. That gives us another remainder pair there. Let's have a test. 8 and 6 is 14. 14 plus 12, 26. Plus 10. So this has to be 9, which means it has to be 4 and 5. And it can't be 4 and 5 because we have a 5 there. So that's 5. That's 8. Now, it means we can do a bit of maths here. So 7 and 9. So now we know that that's 14 and that's 16, right? So, how does that help us? I hear you cry. So 13. We've got 3 solutions. One is 4 and 9. One is 6 and 7. One is 5 and 8. Now it can't be either of the middle ones because, well, 6 and 8 there completely cancels that. So this has to be 4 and 9. 4 and 9. Now we've got 8 here. Now it can't be 1 and 7. And it can't be 2 and 6. This has to be 3 and 5. 3 and 5. 3 and 5, which means this has to be 2. This has to be 3. 4, 5. This means this is 7. Now, this is 10, right? So we know this is 10. So let's start to run pairs, right? So we've got 3 solutions to 7, but 1 means it can't be one of them. So let's put that in. 2, 3, 4, and 5. This is often a way to find entries into the puzzle. 5, 6, 8, and 9. Now we know this is 10. We worked that out earlier on. So it can't be 2 and 8, it can't be 3 and 7. So it's 1, 4, 6 and 9. Now given that, that means that because you've got 4, 9, 4 and 6 here, and 1, 4, 6, 9, this has to be 3. Which means that the pair of this, which is 4, which means that 3 and 5 means that's 3, that's 5. Which means it's going to solve this. Oh, damn it. Okay. It's going to solve this bit as well. And this. So that means that if that's 1 and 9, this is 4. 9, this is 6, this is 4. So there should only be one option for what these are. So one's 4, that's 4. And if that's 4 and 3, that's 7. So that top line, you can't really do anything about it anymore. Okay. Cool. 4, 6, 8, no. Okay, let's do a pair here. So it's 4, 6, and 8. So this means, and 5, can't put 5 into 10. So this has got to be 1, 3, 7, and 9. So this is going to be 2 plus the 10. So 1, 3. So this is going to be 2, 7, and 9. 2, 7, and 9. This has to be 1 or 3. Because you can't put 1 and 3 in there, it's going to be 1 or the other. Now let's look at here, this 12. This has only got a single solution, I can see it. So 3, 5 means this can't be 7 and 9. So this has to be 4 and 8. We've got an 8 along the bottom, so that's 4 and that's 8. And we know that this is 2, 7 and 9, so this can be 2, 7 and 9. Let's look at the pair. Can it be 2 and 9? Yes. Can it be 7? That can't be 7. Because there's a 4. That means this has to be 7. These can't be 7. 3 and 3. Which means that this is 3. And then, so 3 means it's 2 and 7. That's 9. That's 2. So, what else have we got? 12. Now, this 12, I can already see 9 and 8. There's only one solution here. 5 and 7. Which means that up there, that is a 9. That's a 1, 9, 7. So what do we have left over to go in this box? We can have a 1, 2, 3, and that's 6. So let's look at this one. We can probably work out what should go in here. So 6 and 3 is 9, so this would be 5. 6 and 1 would be 7, so this would be 7. And then 3 and 1 can't work because that makes the remainder 10. So it's 5 and 7. So what's the key number here? It's 6, right? So it could be 6 and 1. It could be 6 and 3. So because the 6 has to go in there to make that work, 6 doesn't go in there. Okay, because of this, we can now see this only has one solution, which is 1 and 5, which solves that actually. 7. So if that's 7, then that has to be 7, which means that this is 3. And that's 6, and that's 1. Okay, here is 7, so this can only be one thing, which is 6 and 9. 6 and 9, 6 and 9. So what we've got in here, 3, so this is 9. 9 has 4 solutions. 1, 2, and 3 are up there, so here has to be 4 and 5. There's a 4 there, so this has to be 5. 4, 1, 5, 7, 5. Now, where are we? What's left now? Okay, so we've got this down here, this 13. So that is going to be 2. And then it's something that makes 11. 4 and 7. 2 and 9? No. 2 can't be 9. It's 3 and 8. So this has to be an 8. This has to be 2. This has to be 3. Excellent. Incremental gains, as that cycling bloke says. No, he's a bit of a fraud. Anyway, so 8. Let's scan the middle of this. We've got enough information that we can scan the middle of this puzzle. So then there's 1, and there's 2. 2, then 3, then 4, then 5, 4. Then we've got 6, which can go over here and here. 7 in the middle, which makes that a 2, which makes that a 7. And we've got 9, right? Yeah, that's left over 6 and 9. What else? Okay, we'll do here, this line here, row 7. 1, 2, so it's going to be 3 and 4. That's 3 and 4 as well, because that's the pair of 7. This 7 here can't be 3, 4, can't be 5, so this is 1 and 6. There's a 1 here, which means this is a 6 and this is a 1. That solves that as well. So now we should be able to get the bottom of this done. So this is going to be 9. And there's no 2 there, so this is going to be 2 and 7. Cool. So let's do this line. Let's do this column here. Oh, actually, we can put that in as well. So column 3. So what we've got left. Actually, doing a bit of scanning. That's a 1. If that's a 1, that's a 4. Oh, okay. Feeling a bit spicy today. 4, 3, 4, and 3. 2. Now, because there's 2 here and there's 2 here, that means there's no 2 here. So this is going to be the 2. 3, 4, 5. Okay, 5 can only go here. By scanning, 5 and 7 and 2. What else? So 2, 3, 4, 5. Then we've got 6. Now, that means here is the only place a 6 can go. Oh, damn it, I caught the wrong key again. 6, 1, no, 7 is the last. Next one, 7's up there. 8's there. 9 there. Other than some keying errors, pretty straightforward. See, solved it faster than average. Anyway, hope you enjoyed that one. Hope that gave you an insight into my thought processes, and catch you on the next one.